Uh, I welcome to the first session of the fourth module. So this fourth module, in the fourth module, actually in the first module we have taken an overview of all the non-conventional energy sources and its requirement and the significance of individual energy sources, whether it is a conventional or non-conventional, and we have also discussed what are the different sources of these energy sources, how they are extracted, how much they are being utilized. That is what we have discussed in the first module. Actually, in the second and third module, we have, in particularly, we have gone through the solar energy. It is only because solar energy is a predominant one, uh, which takes a maximum amount of energy harnessing, and it is of higher demand. It is only because this solar energy can be utilized even for the domestic purposes also. That is the reason why we have concentrated more onto the solar energy systems and its performances in the third module. And we have also discussed a few of the numericals and its characteristics to design the solar energy systems and harnessing of it. So in this particular fourth module, we will be concentrating on other type of non-conventional energy sources. Let us go through the syllabus which has been prescribed for particularly the fourth module, and the syllabus will runs like this. So in the fourth module, we will be talking about wind energy properties. In the wind energy, basically I've already told you, wind energy is nothing but the energy that is being possessed by a fast moving air. So that is what we call it as an wind energy. And harnessing this kinetic energy of the air is nothing but we call it as a wind energy, or harnessing of wind energy. So with this wind energy, we will be discussing about different the properties of the wind, and then any non-conventional or any conventional energy sources, the availability is one of the major factor. As I was just talking in the solar energy system also, we cannot use solar energy systems in all parts of the world or in all parts of India. It is only because it is restricted to the availability of the solar energy. Though the solar energy is available in every part of the earth, but still it does varies. Say for example, the solar energy which is available um, in the southern part of India, or in particularly in Haveri or Bangalore, is entirely different than the solar energy or the flux. I mean to say solar flux which is available in the other part, the cold places. So it is entirely different. So it will not be a steady one, and though it is available, it cannot be available in the same intensity for all the 365 days. So that is the one reason. So likewise, even the wind energy, its availability on all the 365 days and all the places will not be remains as the same. So wherever it is suitable, there only we can go for this wind energy. So that is why when we go in particularly with that respect, what is where and all the availability of wind energy in particularly in India is being discussed. And then we will discuss the wind velocity. Obviously, when I say a wind means it will possess the kinetic energy. When I say it is a kinetic energy, it is obviously half mv square, wherein which v is nothing but our velocity. Okay, now, and the power from the wind. What is the amount of power? What is the watts of how much of watts that we are uh, harnessing it from the wind? That is also been discussed. And any energy sources will have its own restrictions or constraints. So in that context, the wind energy, what are the major problems associated with the wind power is also being discussed. And then we we call it as a windmill. So they are also called it as wind machines or wind turbines. So these wind machines, how the harnessing is being done using these wind machines or windmills or wind turbines. So that has been discussed, and then the types of wind machines and their characteristics. Basically, this wind machines are been classified into horizontal axis and vertical axis, and on what uh, occasions or on what reasons this particular type of wind machines have been used, that it will be discussed. And then we will also discuss the characteristics of the wind machines. Then we will discuss in particularly horizontal axis windmills and then the vertical axis windmills we will be discussing in particularly. Then elementary design principles also we will discuss it when we are talking about the windmill vertical and horizontal windmills. Basically this vertical axis windmills are popular in the short form they are called as VAWM, whereas the horizontal wind axis machines are called as HAWM. So, and then we will also discuss the coefficient of performance of a windmill motor. Coefficient of performance, how its performance. See, coefficient of performance, maybe COP we have already, it may be known to you when we talk about the performance of a air conditioning system or it may be a refrigeration system. There also we find out what is the coefficient of performance. That means how much the performance is been rated of a windmill is by the coefficient of performance. We will discuss a small numerical, small formula are there, not so difficult, a simple formula. I just shall go to that later part of the sessions. Then one interesting thing is an aerodynamic considerations. Basically, this aerodynamic considerations plays a vital role in deciding the or designing the wind blades. The blades you might have seen it maximum of we can have a windmills with a single blade or we can also have a windmills with 5 blades. So different number of blades are also, but in most of the occasions we only see 3 number of blades. I'll tell you in particular why we are going for that. And then while designing the blades also we consider this aerodynamic considerations. What is this aerodynamic consideration? That we will discuss it in aerodynamic considerations of windmill design. Then we will have a few numerical examples. Then then we will end up with the wind energy. So soon after the wind energy, we will go to the tidal power. Basically, tidal power consists of two types of energy harvesting: tidal energy and wave energy. Actually, these two comes under ocean energy. When we say it as a ocean energy, in ocean energy we will get a tidal energy, we will get a wind energy, tidal energy, wind energy, and ocean thermal energy conversion. These three ways we can harness the energy systems from the ocean energy. But in particularly, we have put this tidal and wave in one category, that is the tidal power. That we will concentrate in the second chapter of this fourth module, where the tides and waves as energy suppliers and their mechanics we will discuss it. And then the fundamental characteristics of tidal power, then the harnessing of tidal energy and their limitations also we are going to discuss it. So soon after that ends up with the tidal power. And the third chapter in the fourth module we will study about OTEC, that is popularly we always remember it as OTEC. It is nothing but ocean thermal energy conversion system. That uneven heating of the sea water along the depth is been utilized in harnessing the thermal energy into electrical energy. That we will discuss it with the principle of working. And even in that also we have two types of actually open system and a closed system. The closed system is also called as a Rankine cycle. Okay, that we will study the two types, open cycle and closed cycle. But in your syllabus he has given only Rankine cycle. Let us not issue. We shall discuss both so that it gives a clear picture how these entirely different Rankine cycles does works for this OTEC harnessing. Then what all are different OTEC power stations in the world we shall discuss. Actually it is one in the southern part of USC and all those different OTEC power stations which are there. It is actually limited, so only he has asked us to highlight different power stations in the world. Then problems associated with OTEC. Obviously, what are the limitations or the problems associated with ocean thermal energy conversion system also we shall discuss it. So this is all it constitutes in the fourth module. We shall discuss about all the theory aspects and the formulae which are generated for this wind energy and all things. At the end of the module, let us discuss about the numerical examples which are related to this wind energy. Let me get into the wind energy. Basically, what do you mean by a wind? Basically, this wind is nothing but the difference between a air and a wind. Air is something which is surrounded by us. It's the same air which moves with certain velocity. If it moves with certain velocity, then we call it as a wind. Air which is possessing a kinetic energy or a velocity, then we call it as a wind. How it happens, how it is being generated, that I'll quickly go through it, and in detail we shall discuss it on later on. This wind is generated. Now on all parts of the earth we don't get the same amount of wind or the same wind energy, that is air with a certain velocity. It is only because the uneven heating of the earth surface, or uneven heating of the earth and the water surface. Two reasons will makes this wind to generate. Now basically what happens, the land is not the same flat. There will be some mountains, there will be a low level lands. This air which is over here and the air will be unevenly heated because of the solar radiations. So what happens when it is unevenly heated, the air above this ground level and above the higher level will also get heated in a different temperatures. So that what happens, there exists a current flow. Exactly. So what happens, this hot air will tries to move upwards, whereas the cold air will tries to move downwards. So this makes the air to move with certain velocity. Similar fashion, the air above the water and the air above the surface will also unevenly heated. So that once again it moves around. So that causes this wind to blow. Is it clear? Now I'll quickly come to this. Wind power or wind energy describes the process by which the wind is being used to generate mechanical power or electricity. Is it clear? Mechanical power or electricity is being used. Wind turbines convert the kinetic energy of the wind into mechanical energy. So wind turbines are nothing but the devices which converts wind energy or the kinetic energy of the wind into mechanical power, and then further this mechanical power can also be used for converting it to electrical energy. Now my dear friends, one small project that forest people have taken it in the deep forest, when there is a scarcity of water. What they will do is, they cannot go and water the plants in the forest. So what they will do it, that is first thing. And even the animals which are there in the forest, what they will do is, they require the water. They will dig, they cannot pump the water. So what they will do it is, whatever the wind energy is there is being utilized to pump the water from the underground. Are you getting my point? So the wind energy, that is nothing but a kinetic energy, is being converted into mechanical power. So conventionally what we do it is, we convert this mechanical energy into electrical energy. But in such cases what happens, this mechanical energy is being used to pump the water from the underground, like a submarine. Submersible pump. Like the from the submersible, they will run the submersible pump and they will lift the water to the ground. So automatically whenever there is a wind, it pumps out the water. So that is one use of this wind energy. When mechanical energy enhances a unit by harnessing wind power, it may be called as a windmill. Is it right? A wind pump or a wind charger are also being used. See, this is what I have been talking about. This is what we call it as a wind pump. Okay, and then if it is a mechanical energy, it is being used for wind power, then we call it as a windmill, and then wind charger also. Okay, now wind energy can be used for anything from power on boats, battery charging or electricity, to being used commercially. This can also be used for charging purpose also. Is it clear? Maybe recently you might have seen a fellow has placed a wind, a small like a fan or a turbine above the car, so that the charge is being used for the car, maybe for other purposes. So that can be done. Okay. What are the advantages of a wind power? Wind power is a cost effective. Once if you make, I agree it's an initial investment is more. Now approximately as I know it may cost around 1.25 to 1.5 crores for placing or fixing a one wind mills above the mountains or any plains. So once after this, how much ever it rotates, you will get electrical energy. 24 bar 7 you will be getting an electrical energy, provided sufficient wind is there to make the turbine blades to rotate, wind turbine blades to rotate. Okay, now the wind creates jobs. So it is only because it just gives an opportunity for people to operate wind turbines and maintain it. Wind enables industry growth and competitiveness. No, it's only because you can sell the electricity also. If you have a four turbines, whatever the energy that it generates, you can sell the electrical energy. That is what the other company people, for example, Jindal company, they will generate the electricity, they will utilize it how much ever they want it. If it is more than enough, they will sell it for the other companies. So that is what the idea behind of it. It's a clean fuel source. So that means we are not burning anything, no burning and no pollution is there. Wind is a domestic source of energy. It's a sustainable. That means it can be reused again and again. Wind turbines can be built on existing farms and ranches also. It is need not necessarily based on the capacity, just actually even on the mountains or wherever the outskirts of the city is what they keep the windmills. It is for the purpose of wind electricity generation. It is a high capacity. If you want to use a wind turbine, you can place it above your on the roof of your house also, which may generate electricity sufficient enough to use it for one bulb. Based on the capacity, the size of the windmill also varies. Unlike fossil fuels that emit harmful gases, and nuclear power that generates radioactive waste, wind power is a clean and environmental friendly energy source. Compared to these fossil fuels and nuclear power, it has been a very environmental friendly energy. As an inexhaustible and free energy source, it is available and plentiful in most regions of the earth. Exactly right. As an inexhaustible, that means it is not exhausting. It's a free of cost. No need to pay anything for the wind. Are we paying anything for the wind? No, not at all. So it is free of cost. In addition, more extensive more extensive use of wind power would help to reduce the demands of the fossil fuels. Obviously, by utilizing this more and more, we can reduce the demand for the fossil fuels. Ultimately, any type of non-commercial energy sources, our main motto or aim is to reduce the demand for the fossil fuels. It doesn't mean that we are against the fossil fuel. It is only because the fossil fuels makes more pollution and they are exhaustible in nature. So before it get exhaust completely, we have to look for some alternatives. That is the reason why we always compare with the conventional or fossil fuels. That is what, which may run out sometimes in this century, according to that the present consumptions. Furthermore, the cost per kilowatt hour of wind power is much lower than that of the solar power. When it is compared to the cost per kilowatt hour, for 1 kilowatt hour, how much we are paying? It is much less than what we are paying for same 1 kilowatt hour which has been generated by solar energy. Even while talking about solar energy, we have discussed that solar energy, the semiconductors are very costlier, which are made up of silicon or germanium, whether it may be NP or PNP, whatever. Initial investment is very high. Is that clear? So this wind power has got lower than that of solar power per kilowatt hour of generation. Then what are the different properties of a wind? Basically, a wind is nothing but a velocity of a air. When I say it is a velocity, that is, it is in terms of meter per second. When I say it is meter per second, so that means it is a vector quantity or a scalar quantity. It's a scalar quantity or a vector quantity. It is a vector quantity. That means it has got both magnitude and direction. When the wind is blowing, we say in what direction it is blowing, and then in how much velocity with which it is blowing. Then also, so we always term it as a vector quantity because it has got both directions and magnitude. Wind has got two important characteristics: direction and speed. This is what I just want to say. The direction of the wind can be gauged using an instrument called wind vane. So the direction can be maintained or can be identified using a wind vane. Even, my dear friends, you might have seen it, even in the airports, you can see a small a conical cloth will be placed against a pole, a conical cloth. It is always shown in which direction the wind is blowing. If it is moving in this direction, that means the wind is moving in this direction. If it is in this way, obviously it means that a wind is blowing in this direction. It is a simple instrument. Is that clear? It is also called as a weather vane. Every wind vane has two parts, the front and the rear. This wind vane will have two parts. One is the front part and the other one is the rear part. A very common shape of a wind vane is the shape of an arrow. Shape of an arrow. This is actually a different one. A wind vane which shows in the shape of an arrow. The tip of the arrow is the front and the tail will tells us the rear part. If it is an arrow something like this, the tip will show us the front part and the tail will show us a back part or a rear part of wind vane. This is then mounted on a vertical column that is free to move when the wind blows. So it will be always placed like this. It will be always placed like this, and it is been free to move in all the directions, something like this. It is free to move in all the directions. So whenever, in whichever the direction the wind blows, against that it will move. In the same direction of wind, it will move. Say for example, if the wind is moving like this, so this is the direction of the wind. This is clear. So wind blows, it pressure, the front part has a smaller area, surface area than the rear. It is only because it is being point end. The arrow will always have a point end, so it will be a smaller surface area. When wind blows, it presses more on the rear part of the wind vane as it has a greater surface area. So obviously it is having a more surface area, so it just blows and makes this a free point, a lower sharper surface area will be blowing in along the direction of the movement of the air. So that is what we measure, that is how we measure the wind vane, that is direction. The arrow therefore aligns itself such that its tip points the direction from which the wind is blowing. Directions namely north, south, east, west, or maybe northeast, northwest and southwest or southeast. So 8 directions also we can show it, will be marked on the wind vane. So there will be a small a pointer like circular gauge will be there, which tells us the 4 directions of the wind. Then another common shape used in a wind vane is that of a rooster. This is what I was just talking. A rooster is being used. The head has a smaller surface area than the tail and the point in the direction from which the wind blows. Okay, for an accurate reading, the wind vane should be located well above the ground, beyond the trees and other buildings, which may interfere with the wind direction. So obviously it is a common sense that this should be a free. In the 360 degrees, it makes sure that the wind which is blowing against to this wind vane should not be restricted with any type of air restrictions. So wind should blow against to this freely, so that it tells us in which direction the air is being blown. The speed of wind is usually measured with an instrument called anemometer, which are also called as anemoes. Basically, we have wind vanes are used to find out the directions, and the speed or the velocity is being measured using anemometers. Anemometers are also called as anemoes. Anemoes are wind. Anemoes means wind. So in the a type of anemometer called cup anemometer, there will be one cup of anemometer. Maybe my dear friends, you might have seen it. A series of cups will be there. If you take like this, like a plus mark, or it may be in a cross mark, at the end of this there will be a series of cups will be there. You might have seen it. In a type of anemometer called cup anemometer, there are 3 or 4 cups mounted symmetrically at right angles to a vertical axis. That means if this is a pole, and above this we will have something like this, and in this what happens, we will have a series of cups. It may be varying from 2 number of cups to 3 number of cups, or it may be 4 number of cups will be there, and they have been placed exactly like this, that is in the 90 degrees, symmetrically 90 degrees to the vertical axis equally. The force exerted by the wind is greater on the inside surface of the cup. Obviously the cup will be like this. A cup will be like this. So what happens when the wind blows against this? The inside surface of the cup is the wind exerts more force. Force exerted by the wind is greater on the inside surface of the cup than the outside. It is only because the wind which is exerting over here will escape out like this, which slides over here, and the force which is exerting over here, it has to take the wind away along the curvature of the inside curvature of the cup. So if it is striking over here, if this is the wind is coming and striking over here, it has to go out like this. So that is the reason why the force which is being exerted inside the cup is more than the force exerted at the outside surface of the cup. Is it clear? So that what happens here is, due to this, the cup starts rotating. Once if it starts rotating, how long? This is something like a reaction effect. It is something like a reaction effect, impact effect and reaction effect. Reaction forces, it is something like when you take a balloon and puff the air, if you suddenly open it, what happens? The air will start coming out, and the reactive forces will act in the opposite direction. Though the air is going out in this direction, the reaction force will be in opposite direction. The same way, the wind which comes over here will try to escape out at the tip, so that what happens? This makes the cups to move. This is called as a reactive force of action. Due to this, what happens? The rate of rotation is directly proportional to the wind speed. How much ever the wind blows over here, the velocity, it is directly proportional. If the wind force is less, then the cup speed will also be less. If the wind speed is maximum, the cup speed will also be maximum, and it will be placed in a vertical axis, and it is free to rotate, and this is mounted in such a way. Is that clear? So the faster the wind speed, the faster the cup rotates. It's a common sense. The slower the wind speed, the slower the cups rotate. Cups anemometers are mainly used by Meteorological stations. Meteorological stations, as I have already told you, they deal about the changes which are happening in a climate or in the earth atmosphere, whether it may be a wind or it may be a earthquakes or it may be a, tsunamis or whatever it may be. Any change in the atmosphere or the climate is dealt by these meteorological stations, and these cup anemometers are popularly used in the meteorological stations. Thus, this this is how the wind vanes and anemometers are being used to find out the direction of the wind and the power or the speed or the velocity of the wind respectively. Wind vanes for the directions and for the wind speed or velocity, anemometers have been used. These are all the different characteristics or the properties of the wind.